Okay, total analogy with momentum and all the reasoning. You have, if you have two interacting objects with angular momentum, they exert equal and opposite torques on one another. With the result that if they're in an isolated system, the net change in angular momentum has to be zero, because the torque exerted by one object is equal and opposite to the torque exerted by the other, right? And you have the angular impulse momentum theorem that ensures this the same way the impulse momentum theorem ensures that MV, total MV of a system remains constant, an isolated system. Okay? Hopefully you're conversant with that. Okay. So that's it. Now, if we have two objects interact and become one, again in an isolated system, right? So I should say in an isolated system, where two objects isolated from the rest of the universe, okay? Interact and become one. Now we can say this: total angular momentum before equals the total angular momentum after. After, you have only one angular velocity, since the two objects are now joined, right? And we've done that in lab, you know, when you drop the two magnets on the rotating beam, right? And you've had problems that ask you to work on that, so hopefully you have some fairly good idea of what this means. Okay? So, yeah, there's, I knew there was one more thing I had to say, and, you know, short-term memory here. Where your moments of inertia are measured with respect to some fixed axis. Now there's a subtlety that arises there that we're not going to deal with today. We'll just deal with the very simple mathematics of this. Okay? You got this parallel axis theorem thing that has to be applied here to make this work. Okay? And we haven't talked about parallel axis theorem. Yeah, we'll save that, because that's a little challenging. Okay? So, make sense so far?
Is L angular momentum, like capital L?
We use, it's not a universal symbol. I believe your text uses it. I believe it's probably the most common symbol for angular momentum, but it's not totally universal. Different authors might use different symbols. It's not as universal as M for mass or I for moment of inertia. Okay? So don't take that as a symbol that everybody uses, just kind of like some of the symbols I use. Okay? using a delta W. That's kind of weird to people that aren't used to it, okay? Again, I use that because I'm talking about the work done on some interval. So during some time interval or some specified time interval or some specified interval of displacement, whatever, okay? Okay, so anyhow, that's what we have. Okay, very simple at this point to apply this.